Hello all, welcome to Climate Change Solutions. It is a US based startup. So we work on researching and developing solutions to pressing issues related to climate change and global warming. So one of the key project that I am working on is on-the-go charging of electric vehicles. So the electric vehicles, there are four major concerns. One is range anxiety, very limited range. The second problem is public charging infrastructure is not available everywhere in most of the countries, and it also adds to traffic in countries like India. And third problem is it's time consuming, and most apartments in India don't have charging facility in the parking space. So there are many problems, right? Let's say the vehicle breaks down in the middle due to dead battery. So how can you? So it's going to ruin your day, right? You have to get a help from somebody else to continue the journey. So I got this idea a few years ago in 2022. So I thought for a second, and like every vehicle in a motion experiences a wind that is so strong that can generate electricity using a wind turbine. So I believed in that idea. I wanted to pursue that for project. So I reached out to a couple of people, and they said it's not possible. Only regenerative braking is working. So even then I believed it can work, and I tried looking into different options like which wind turbine to use, and how to mount it on the vehicle. When I was testing with the traditional generators, the power output is substantially low at low speed. So if the vehicle speed is above 40 kilometers, so it's somewhat moderate. But I wanted to generate a massive power. So I was looking at the drawbacks of a generator, and in a traditional generators the mechanical input required to generate a power is very high. So this is because stator also becomes a strong magnet under a load. So I was trying to look at the causes of stator becoming a strong magnet. So if you look at this stator, you see this gap. There is a gap, right? As you can see, this gap. So because of this gap, the flux lines extend and they become a strong magnet for a rotor. So this is going to induce a drag force on the rotor, which is why the traditional generators need very high mechanical input to generate a usable power. So to give you an analogy how we can overcome this problem, so I have this rotor, right? So I have this north south alternating magnets. So I attached it to the iron disc. Okay, so if you look at this side, which is not attached to any metal, see, it's a strong metal, right? So it sticks, see. But if you look at this side, this is not a strong magnet. Why? Because this iron disc provides a better path for magnetic field lines to travel. So the field lines redirected in the disc, so there is no need to travel away from the disc and attract other objects, right? The same principle we can apply it in the generator stator. To prove my point, so I created a stator. So this is a stator I created to prove my point that when we enclose a stator with the core, see, it's not going to be a strong magnet. So I created this stator, and I don't see any difference in the mechanical input required under load, but the voltage output is significantly low. It's not generating enough power because the field is not traveling to coil like before. So I know why. Because when you have a gap, the flux lines from the rotor bind to this edges, and they travel easily. But when you close this, it will not attract very well to magnet, and the magnetic flux induced in this coil is very less. So I have a solution for that as well, which I am working now. So I will share that video. But this is an interesting project because it's a more than 100-year-old problem, right? It's been like this for more than 100 years, and if this project goes well, it's a game changer in the wind energy and hydroelectric projects. And we are also solving lot of other problems like for flying vehicles or even drones. We need extended range. So this project is a key project for climate change solutions inc. It's going to reduce a global carbon footprint and increase EV adoption. So that's all I want to discuss in this video. I hope you like this idea, and I wanted your support. I wanted everybody to know that this can be possible, and if you really want to help me, please like and share and subscribe. See you in the next video. Thank you.